right? Can you hear me?
Yes, sir.
Yeah, fine.
Yes,
Okay.
sir.
And also hydrogen ion concentration, right? So in the pH, right? pH that is equal to what? Negative log the base 10, the concentration of H plus ion, right? And also pOH, pOH that is equal to what? Negative log base 10, the concentration of OH minus ion, right? So then ionic product of water, so which means Kw that is equal to what? The product of the concentration of H plus ion and OH minus ion at 25 degrees Celsius, and it is equal to 1 to 10 to the power of minus 14 mole square per dm, right? It's about ionic product of water. Then what is the relationship between ionic product of water and temperature? So when the temperature increases, ionic product of water also increases, right? So what about concentration of H plus? It is also increases, but pH decreases, right? But pH decreases. And these are the observations. Here, Kw gets larger as the temperature increases, right? So this means the concentration of H plus and OH minus ion gets greater. Why? Because dissociation will be more. So when if you increase the temperature, dissociation will be more, right? So this means equilibrium has moved to right, has moved to right. Okay, if the concentration of H plus increases, then what about the pH? pH decreases, right? pH decreases means temperature increases, and it is endothermic process. Okay, it is endothermic process. Why? Because we need to put temperature, right? We need to put temperature. Nothing but energy in terms of temperature we need to put, right? So energy is needed, energy is required, which means the process endothermic, right? If the energy is released, then it is exothermic, right? Okay, then a relationship between the pH and pOH, right? So here the relationship between pH and pOH that is equal to what? pH plus pOH that is equal to 14, right? So that is the maximum value of pH, that is 14, and it is true at only stated temperature, nothing but 25 degrees centigrade. And here, look at the chart. Strongly acidic means what? pH value 0 to 2, right? And weakly acidic in the sense 3 to 6, like that. Neutral in the sense pH that is equal to 7. Weakly alkaline or weakly basic means 8 to 10, 11 to 14, that is strongly alkaline nature, right? So look at the chart. And okay, today we are going to discuss the problems. So in that, the first thing is, can you see my screen?
Yes, sir.
Yeah, okay. The first thing is calculating pH of strong acids as well as alkalis, nothing but base. Okay, strong acids and strong bases. So as you know that, what is the pH value for strong acid? Strong acid, or simply acid. pH value
0.
1 to 4, sir.
1 to 4. Strongly acidic in the sense, okay, 1 to 3 you can consider, no problem. 1 to 3. Similarly, strong bases,
14.
yeah, 8
11
to
to 14, sir.
yeah, 11 to 14, yeah, no problem. 11 to 14 on, right? Strong acids and bases. Okay. Then how we are going to find out the pH value? If you are knowing the concentrated solution, means some concentrated they given, like a 0.1 molar HCl solution, 0.1 molar NaOH solution, like that. Then how we are going to find out the exact pH value? Any idea? So if you are having 0.1 molar of HCl solution, okay, 0.1 molar of HCl, then what is the pH value exactly? How could you tell that? pH value of 0.1 molar HCl solution, like that. Similarly, for bases, 0.1 molar NaOH, like that. How could you say that? Any idea? How we are going to calculate them?
You should first see the concentration of H plus, sir.
Exactly. So it is very easy in case of strong acid and strong bases. The strong acids and alkalis, as you know that it is completely dissociate in aqueous solution, right? Strong acids and alkalis is completely dissociate in aqueous solution. So completely dissociation means what? It is very easy to calculate the pH by just knowing the concentration. Okay, you just know the concentration, then it is very easy to calculate the pH of particular solution, right? Particular solution. Okay, let us discuss this example. Here, the calculate the pH of 0.02 molar of HCl. Anybody Anybody else? What is the exact pH value for this? 0.02 molar of HCl. Can you calculate this?
2, sir.
Is it 2?
I
Is it
think
2?
so. Yes, sir.
Okay. Then how we are going to calculate it? Okay, as you know that HCl is nothing but what? Is it strong acid or weak acid?
Strong acid.
Strong
acid.
acid.
Okay, dissociation of HCl, it gives H plus and Cl minus n, right? HCl completely dissociate in aqueous solution and it gives H plus and Cl minus. So here what happens, look at the point carefully here. One H plus ion is produced, okay, one H plus ion is produced for each HCl dissociating soap, which means HCl is completely dissociating, right? HCl is completely dissociating. Why? Because it is strong acid, right? It will going to convert into H plus and Cl minus. Completely in the sense, as much of the concentration, that is 0.02 molar of HCl is there, right? That is going to completely convert into H plus and Cl minus, right? So what happens here? One H plus ion is produced for each HCl dissociating soap. So what happens? The concentration of H plus becomes is equal to 0.02 molar, right? 0.02 molar. Just take this one, 0.0 molar in the sense 2 into 10 to the power of minus 2 moles per dm cube. Just convert into moles per dm cube, right? 2 into 10 to the power of minus 2 moles per dm cube, right? So here you're getting, look at that. Here you're getting, what is it? Concentration of H plus ion, right? The concentration of H plus ion. Then how we are going to pH value, find out the pH value by knowing the concentration of H plus ion?
Minus log of H plus.
Yeah, just put the value in a pH equation. Okay, pH equation, what is that? pH that is equal to what? Negative log of H plus, right? Negative log of H plus. Just put the values of H plus here. Just apply negative log. What is the pH value here? What is the pH value? Then look at this. What is the pH value?
1.7, sir.
Yeah, 1.7. 1.7. Now tell me, is it strongly acidic or weakly acidic?
Strongly
1.7.
acidic.
Strongly acidic, right? Got it now? Similarly, taken for this basic solution, just calculate the pH of 0.1 molar in your solution. Now tell me, what is the value of pH? Anybody else? 0.1 molar of NaOH. Just calculate and tell me, what is the value of pH here? Anybody else? Am I audible?
Yes, sir.
Yeah, fine. Just calculate and tell me. You know that NaOH is nothing but a strong base, right? So strong base in the sense you'll get a pH value. Just remember one thing. I think 11 to 40 something. In that range only it will come, right? But we know the exact pH value, right? We need to know the exact pH value. So that you should calculate according proper calculation you have to do, right? And tell
Sir,
me
is
what is the
13.7, sir.
13.7. Yeah, that which. So here the NaOH, as you know, that completely dissociate into aqueous solution. So that NaOH gives Na plus and OH minus n, right? So here, what firstly we should know the concentration of OH ion, right? Why it's a basic solution, right? The first thing you have to know that is the concentration of OH minus n. So here one OH minus n is produced for each NaOH dissociating, so right? So one OH minus n is produced for each NaOH ion is dissociating. So here the concentration of OH minus that is equal to 0.1 molar, right? 0.1 molar. So that is nothing but 1 into 10 to the power of minus 1 mole per dm cube, right? Mole per dm cube. So here is just, so what we get, the concentration of OH minus n, right? So by knowing the concentration of OH minus n, how do we calculate the pH? So here by using the two equations, like that is Kw, ionic product of water. Kw that is equal to what? H plus and OH minus n, right? H plus, the concentration of H plus and OH minus ion, right? So here, just take it out, H plus ion in this equation. Just take it out, H plus ion in this equation. So what we will get, H plus ion concentration, that is equal to Kw divided by concentration of OH minus ion, right? H plus ion concentration, that is equal to Kw divided by concentration of OH minus ion. So as you know that the value of Kw and also here the OH minus ion concentration. You put the values, then you will get the concentration of H plus ion, right? Then you will get the concentration of H plus ion. Once you know the concentration of H plus ion, so you just put the concentration of H plus ion value in pH equation. So finally, what we will get? The pH value, right? Finally, sorry. Yeah. Can you see my screen?
Yes,
Can you
sir.
see? Yeah. So the final value is 13 only. Okay. The final value, nothing but pH of 0.1 molar NaOH, that is equal to 13 only. Okay. Again, I repeat. Any doubts in that? The second thing, 0.1 molar NaOH. Just ask me. Okay. If you have any doubts here.
So please, can you repeat?
Yeah. Okay. So look at this. So here, while taking a basic solution, so you may get the concentration of OH minus ion, right? You may get the concentration of OH minus ion, and this is the value, right? The concentration of OH minus ion. This is the value. Okay. So here, you just look at this Kw, nothing but anionic product of water. As you know that Kw, that is equal to what? H plus ion concentration and OH minus ion, nothing but product of H plus and OH minus ion, right? Concentration of H plus and OH minus ion, right? So, but we should know the pH value, right? Then how we are going to calculate the pH value? So pH depends on what? Concentration of H plus ion, right? So first we need to know that the concentration of H plus ion. Just take it out, this one. In this equation, just take it out. So then what you will get? Kw divided by concentration of OH minus ion, right? Kw divided by concentration of OH minus ion. So here the value is there, OH minus ion concentration. And Kw, what is the value of Kw? 1 into 10 to the power of minus 14 mole square per dm cube. This is the value Kw, right? So this is the value of Kw. Okay, just Kw divided by OH, concentration of OH minus ion. So then you will get the concentration of H plus ion, right? The concentration of, can you see my screen?
Yes, sir.
Yes, sir.
Yeah, Kw divided by concentration of OH minus ion, then you will get the value of H plus ion concentration, right? So once you get the H plus ion concentration, then you just put in this equation, pH is equal to what? Negative log of the concentration of H plus ion, right? Concentration of H plus ion. So finally, you get the value of pH. Okay, that is nothing but 13 only. Okay, any doubts in that? Any doubt? Can you hear me? It's very easy, just mathematical formulation. Okay, don't get confused. So here, in case of a basic solution, what happens? So we need to know OH minus ion concentration, right? Firstly. So then you put it in anionic product of water. Okay, anionic product of water. So there you will get the concentration of H plus ion concentration, right? The concentration of H plus ion. Once you know the concentration of H plus ion, definitely you put the values in pH equation. So once you put that value in pH equation, definitely we get the exact pH value. Okay. So this is about calculating pH of strong acid as well as strong bases, right? Strong acid as well as strong bases. Then how we are going to calculate the weak acid, pH for weak acid? Any idea? Calculating pH for weak acid. So weak acid, as you know that, is it undergo complete dissociation?
No, sir.
Incomplete.
So it means partial dissociation. So in that cases, then how we are going to calculate the pH? Is it possible to calculate by just knowing the concentration? Is it possible to calculate the just knowing the concentration? So it cannot be calculated by just knowing the concentration. But what happens here? So need to know the original concentration and extent of ionization. Okay. So need to know the original concentration and the extent of ionization or else dissociation. Okay. So that ionization is given by, the extent of ionization is given by in terms of Ka. Ka is nothing but what? Acid dissociation constant. Similarly, Kb. Kb in the sense, what is that? Dissociation constant for a weak base, right? Weak base. Km is what? The dissociation constant for a weak acid. Similarly, Kb in the sense dissociation constant for a weak base, right? So first, we need to know the dissociation constant in case of weak acid. Okay, in case of weak acid. So based on that, we have to calculate the pH. Okay. First, we will discuss about the dissociation constant for a weak acid. So, okay. Look at this. Dissociation constant for a weak acid, Ka, that is equal to what? So a weak monobasic acid, if you consider a weak monobasic acid, that is Ha. Okay. And this is Ha, representation, nothing but monobasic weak acid. Monobasic weak acid undergo dissociation. It gives a conjugate base and acid, nothing but conjugate acid base pair. Okay, conjugate acid base pair. So applying the equilibrium law, you may get a constant that what is called Kc, equilibrium constant, right? So applying equilibrium law, you may get equilibrium constant, that is Kc. K nothing but equilibrium, and here the constant equilibrium constant Kc, that is equal to what? A concentration of the product, product over concentration of the reactant. Here, concentration of the product nothing but what? Concentration of H3O plus and A minus divided by the concentration of weak acid as well as the concentration of water, right? Concentration of water. And got this. So let us consider one assumption here. Let us consider one assumption. For a weak acid, there is little dissociation. As you know that for a weak acid, there is little dissociation, which means Ha is nothing but what? A weak acid in equilibrium. Okay, again I repeat, Ha, nothing but weak acid in equilibrium condition, it remains as undissociated only. It remains as undissociated only, which means it is not going to dissociate into respective ion. In equilibrium state, it remains as undissociated molecule only. Okay, so this is the equilibrium condition, and this assumption becomes less valid for stronger weak acids. The point should be noted, this assumption becomes less valid for stronger weak acids, where there is more dissociation. It means weak acid. Okay, weak acids, we observe very little dissociation, but stronger weak acid, the point should be noted, stronger weak acid, if you consider, so we expect some more dissociation compared to very weak acid, right? Very weak acid. So in that cases, this assumption is not valid. Okay, in that cases, this assumption is not valid. Assumption in the sense that is equilibrium condition. Equilibrium condition. So here the weak acid remains as undissociated. That is the assumption. Okay, that is the assumption. So here in dilute solution, the concentration of water is large compared with the dissociated ion. So and any changes to its value are insignificant, so that it can be treated as a constant. Okay, dilute solution, we take concentration of water, it should be an excess quantity, right? Or else the larger quantity is present, right? So that any changes to its value are insignificant, so that we can consider the constant value here. So here, just combine this, you may get a new constant, that is Ka, nothing but acid dissociation constant, that is equal to what? The concentration of the product over the concentration of the reactant. Here, water can be treated as constant, so that just taken as the concentration of a weak acid, concentration of weak acid, nothing but Ha. Okay. So why? Because water, we can take it as a constant value. So here, therefore, a simpler way to express the dissociation is simply just consider a weak acid dissociation. So it may dissociate into H plus and A minus ion, right? H plus and A minus ion. Then the equilibrium constant is given by Ka is equal to concentration of H plus and A minus ion divided by the concentration of weak acid. Okay, the concentration of respective ions over the concentration of the weak acid, nothing but Ha. The respective ion in the sense H plus and A minus. Okay. So dissociation constant, that is equal to what? A concentration of respective ion, that is H plus and A minus divided by the concentration of a weak acid. Okay. And it can be represented moles per PM cube. Okay. Here, look at this. And you just note the points here. Yeah. So here, if the acid is weaker acid, okay, if the acid is very weaker acid, so what happens? Less it dissociates, so smaller Ka values, okay, smaller Ka values. So for less weaker acid dissociation constant, we may get smaller, okay, smaller Ka values. For stronger the acid, larger Ka values, okay. Strong acids in the sense Ka will be larger. Ka will be larger. Nothing but acid dissociation constant will be larger. So we can expose in terms of pKa values. Okay, pKa values. So very weak acids have small Ka values. Okay, so it is easier to compare the strength as pKa values. Yeah, which means a weak acid having smaller Ka values and stronger acid having larger Ka values. Got it? So now we are going to calculate the pH for weak acid. So while calculate the pH of weak acid, we just know the dissociation constant for weak acid. Okay, just know the dissociation constant for weak acid. So look at this. So as you know that if you're applying the equilibrium law, you may get dissociation constant, that is the concentration of respective ion divided by the concentration of weak acid. So here, as you know that ion forms are equal amount, right? Ions form are equal amount, so that the concentration of H plus ion becomes equal with concentration of A minus ion, right? So the concentration of H plus ion, that is equal to, that exactly equal to the concentration of A minus ion. The respective ions becomes equal, right? So they are formed in equal amount. So we just consider this case. So we consider this case, just put the value in this equation. So here H plus and A minus become H plus. So which means the concentration of S whole square. Okay, because of this assumption. Okay, don't get confused here. Here the ions are formed in equal amount. So the condition is the concentration of H plus n, that is equal to the concentration of A minus n. Okay, here in place of A minus n, just put one more the concentration of H plus n according to this condition. Then you will get the concentration of H plus n whole square, right? Concentration of H plus whole square. Okay, the remaining thing as usual. So then, so just rearranging this equation, you make it like that. So here from this, just take it out this. So we just wanted to the concentration of H plus. Here the concentration of H square is there, right? So here the concentration of H plus. So here you may get a square root, right? So because of that, you may get square root of this, right? Square root of the concentration of weak acid and Ka. Just mathematical formulation. Don't get confused here. Okay. Look at this. Here the concentration of H plus ion. Here this is the concentration of H plus ion. So by putting these values, nothing but concentration of weak acid, right? Ha, nothing but concentration of weak acid and Ka, acid dissociation constant value. So you may get the concentration of H plus ion, right? You may get the concentration of H plus ion. Once you get the concentration of H plus ion, and you know that the concentration of H plus ion depends on what? pH, right? Concentration of H plus ion depends on pH. So as you know that pH that is equal to what? Negative log of the concentration of H plus ion, right? Negative log of the concentration of H plus ion. So by that, just calculate the exact pH for weak acid, right? So just take the equation here. Just take this equation. So while calculating the pH of weak acids, just knowing the concentration of weak acid as well as the acid dissociation constant. Okay, acid dissociation constant. So wait a second. In this equation, just remember this equation: the concentration of H plus N, that is equal to square root of HA, nothing but a concentration of weak acid into dissociation constant. Once you know the concentration of H plus N, so just put the values in pH equation. Then you will get exact pH. Okay. So let us solve one example. Simple example. Calculate the pH of weak acid, nothing but HX. I just mentioned here HX, weak acid, nothing but HX of the concentration, that is 0.1 molar, and here the Ka value, nothing but acid dissociation constant value is given. Okay, acid dissociation constant value is given, that is 4 into 10 to the power of minus 5 moles per dm. Okay, just consider this equation. Just consider this equation. Okay, so calculate that. Calculate it. The concentration of H plus N, that is equal to what? The concentration they given, concentration of weak acid, that is 0.1 molar, right? Then Ka, right? And what is the value of pH? Just calculate and tell. Can you hear me? Hello, can you hear me?
Yes, sir.
Yeah. Just put the value, concentration of weak acid, so into Ka, right? Square root of concentration of weak acid into Ka. Here the concentration of weak acid, that is 0.1 molar. So into Ka, nothing but 4 into 10 to the power of minus 5.
Sir,
H.
2.4 I got, sir.
Okay, let us check. Okay, here the concentration of H plus N, that is equal to 0.1 into 4 into 10 to the minus 5 moles per dm cube, right? So here the concentration of H plus N. Once you get the concentration of H plus N, so just put the 2.0, nothing but 2.10 to the power of minus 3. So once you get the concentration of H plus N, then what we can do now?
pH, sir, minus log of.
Yeah, pH, that is equal to negative log of H plus N. Yeah, then the exact pH value is 2.69, right? 2.69. Got it now?
Yes, sir.
So you just got the difference. While calculate the pH for strong acid, you just need to know the concentration. That is enough. Okay, that is enough. Okay, but you should be careful while calculating a pH of strong bases. Okay, just take the ionic product of water. Based on that, how to calculate. So, and one thing you should know that once you get the concentration of H plus ion, then it is very easy to calculate the pH. Why? Because pH depends on concentration of H.
Sir,
Formula. pH
excuse me, sir.
negative. Yeah.
Sir,
Tell
I
me.
have a doubt, sir. How many decimal places should we take the log for?
2.6, that is enough, no problem.
Okay, sir. Sir, and if you add water to weak acid, there will be more dissociation, right? I did not get that point where you said it is constant, sir.
Not possible. No, it is not possible. In case of weak acid also, so dissociation is very less, even though it is dissolved in water. Dissociation is very less.
Yes, sir. If on dilution, there won't be more dissociation, sir.
If suppose if you take 1 drop of HCl in 100 ml of water, then tell me what is the dissociation or else dilution? You may
There
get
will be it will be constant.
why? Because
It's a strong acid, no HCl.
strong, even though it is a strong acid, I agree with you. But so if you take
Yes, sir.
extra in larger quantity of water, put
Yes,
100
sir.
ml of water, so just take 1 drop of HCl in that. What is the dissociation then?
It will be 0.1 only, I think. 0.1
Okay, suppose
molar.
one molar of HCl is there. So 0.1
Yes, sir.
molar. What about the dissociation?
It will be same, sir.
So will be same. Then you will get the same pH value for both solutions.
Yeah, yes, sir.
0.1 molar of HCl and 0.1 molar of HCl. You may get same pH value.
Yes, sir. You get same pH value.
No, it is not possible.
1.
Just imagine 1 molar is there, 0.1 molar is there. Just got the difference.
Sir, it'll be lesser pH, sir.
Yeah, that is what. The dilution
sir.
is more, you may get a pH low pH, right? Dilution is more. Okay, but
Yes.
water is present in excess quantity, you taken as a constant value. So it will be
Okay,
strong
sir.
in matter, okay? But if you
Okay.
dissolve the weak acid in water, so
Yeah.
even we cannot expect a more dissociation in that.
Okay, sir. Yes,
Why?
sir.
Because you know that weaker acid undergo partial dissociation only. So in that only we have to differentiate very weak acid